guys, so in this video we're going to go over input-output relationships for resistor circuits using DC sources. And this input-output relationship is known as a transfer function. And a transfer function is the central lesson to ELEC 241. Whenever we're looking at a system, and a circuit is an example of a system, the function that describes inputs to their outputs is known as the transfer function. And so for these types of problems, my mode of attack was to compress the circuit. And by compress, I would simplify down equivalent resistances until I could find important voltage values. And then after I would compress the circuit, I would expand it out again in order to find the input-output relationship. And so that description was a little bit wonky, so let's just go through the process and I'll show you what I mean. Oh, and another point here is I just wanted to make a note that in a lot of Dr. Johnson's problems, he likes to put two prongs to represent V out, right? There's usually a plus prong and a minus prong. But if you have a ground node labeled within your circuit, it's very redundant to put that second prong because voltages are always measured to a reference. And when you have a ground node, you know what that reference is. So V out is measured across R4, and it's only measured across R4 because that ground node is labeled. Anyway, let's go on with compressing the circuit. So the first thing I notice is that R3 and R4 are in series, so I can go ahead and simplify that. And you might think it's odd that V out's in between, and I still want to simplify down these resistors, but we're going to go ahead and do that because you'll see how it's important later. So I'm just going to redraw the circuit with R3 and R4 in series. All right, so we have R1, R2, and then R3 and R4 are now a single resistor. Again, that's using the series rule. And so we know that the V out that we want to find is in between R3 and R4. Well, if we want to find this V out, it would be very useful if we could find the voltage here. And we could find the voltage here by noticing that R2 and then R3 and R4 are in parallel. If we simplify down these two resistors into a single parallel equivalent resistor, we can find the voltage across that one, and we know that that voltage is equal to this voltage here. So let's go ahead and do that, right? We're going to redraw the circuit, and we're going to put those two resistors in parallel. So we still have R1, and now we have a single resistor, which is R2 parallel with R3 plus R4. And let's go ahead and use our parallel resistors rule to figure out what that resistance is. So we know that it's the multiplication of the two resistors, so it's R2 times R3 plus R4 all over the sum of the resistances. So then that would be R2 plus R3 plus R4. And I'm just going to call that R prime because I don't want to write that over and over and over. And this here is still R1. So remember, we were trying to figure out what this voltage is. And when we compress these two resistors into a single equivalent parallel resistor, this voltage here is the same as this voltage. So if I can figure out this voltage, I can figure out this voltage, which helps tell me V out. And so at this point, solving for this voltage is very easy. This is just a simple use of Ohm's law, right? So what we're going to do is we're going to figure out the current that's going through this loop. And then once we have the current, we can figure out what the voltage is across that resistor. So what's the current running through the loop? All right, so we're going to say I for current. And we know that's equal to V over R, right? And so that would be V in. And what's the total resistance of this loop? It's the sum, right? So that would be R1 plus R prime. R1 plus R prime. And then from that, we can figure out what this voltage is by multiplying by R prime. So we get V in all over R1 plus R prime times R prime. Cool. So now we know what this voltage is. But that voltage is still not V out, right? So I'm just going to call that V prime. Okay, we're almost done. Ooh, a little bit hard to draw there. That's V prime. Okay, so now we know what this voltage is. So the final thing we have to do is figure out across these two resistors how is V prime related to V out. And well, that's simple, right? Because they're just in series. So all we have to do again is do a little bit of multiplication. So what we're going to do is V prime all over R3 plus R4 times R4 is equal to V out. And so again, this is just a use of Ohm's law. We know that a total V prime voltage goes across these two resistors, so we can find the current, and that's the V prime over R3 plus R4 that goes through the resistors. And then we want to find the voltage across R4, which is V out. We just multiply by R4. So as you can see here, we have an input-output relationship. We know what V out is, and we know how it's related to V prime, and we know how V prime is then related to V in. So let's go ahead and plug into the numbers of this circuit and figure out what the voltage is at V out. So first off, let's solve for V prime. And to do that, we need R prime. So what's R prime? Since all the resistors are 1, because I like to make problems simple, we know that R prime is equal to 2 all over 3, right, 2/3, okay? And then we know that V prime then is equal to V in, which is equal to 10 volts. Oh, let's just go ahead and write 10 volts in there. All over 1 plus 2/3, which is equal to 5/3, times another 2/3. And of course, we know that is equal to 10 times 2 all over 5, which is equal to 4. Okay, cool. Now we know what V prime is, and so we just have to solve one more time to figure out what V out is. All right, so then we know that V out is equal to 4 all over 2 times 1, which is equal to 2. Okay, so for this example, we figured out what the transfer function was. We figured out a relationship between V out and V prime, which again related to V in. And then from that, we were able to plug in our values to figure out what V out is actually equal to. And so I also modeled this circuit in SPICE, so let's go ahead and verify that our answer is correct. So as you can see here, this is the same circuit. We have a 10-volt battery connected to ground, and then we have 4 resistors, all are 1 ohm. And so I started a transient analysis, which just measures the voltage at this point from time 0 to 5 seconds, measuring at every 1/10 of a second. So let's go ahead and run this. And then I'm going to click here to figure out what the V out is equal to. And as you can see here, it's equal to 2 volts, just as we had calculated. And so I hope this video helped. Remember, the important thing is input-output relationships. You can compress down a circuit by figuring out equivalent resistances till you get to a point where you find an important voltage. And then you can re-expand the circuit until eventually you find V out. I'll see you guys in the next one.